Hello everyone, welcome back to another session by K21Academy. Today our expert trainer will be discussing about serverless computing. So let's get into the video.
The serverless computing. When we say serverless, that means what? It's not so that there is no server which is launched. It is actually you don't have to manage those servers. It is Amazon who is going to manage the server. So server will be there. It's not so that there is no server actually. Servers are there, but you can build and run your application or your code without worrying about the underlying server. It will be a fully managed server. You will not be having any access to the server. It is a fully managed server which will be created, provisioned, and scaled by AWS. So you will be just sending the requests on the server. The amount of compute which is required to execute that particular request will be automatically taken care by Amazon. If more compute is required, it will be scaled up. If less is required, it will be scaled down. So that all process will be taken care by Amazon. So it is a fully managed, provisioned, and scaled by Amazon. So whatever service or whatever function you do, it will be done by Amazon. You don't have to worry about the server. You just worry about your code that you want to get executed or your application that you want to run. You don't have to manage or provision any server. So that is known as serverless computing. And biggest benefit that you have out of this is you don't pay any charges when you are not executing your application. So when there is a normal EC2 instance on which you load your application or your code, what is the issue, or you can say the limitation that you have? Even if nobody is hitting the application and using it, still you need to pay for that reserved EC2 instance that you have created. But with serverless computing, you don't have to pay when your application is idle or your code is idle. It is sitting idle, you don't have to pay for it. Only pay when the function is getting executed. Only you have to pay at that time. And you have very less components to manage. Only your code that you need to manage. So that is known as serverless computing. One of the examples of serverless computing is Lambda. Lambda is what? Lambda is a serverless compute platform where you can run your code of many types without the need or the requirement of managing the backend which is required to run that particular code. You won't be requiring any server to manage on which the code is getting executed. Amazon will be managing those servers. That compute service which is required to execute the code that you have provided will be taken care by Amazon. And it is a event driven procedure. So it's like a sleeper cell. It keeps on sleeping till the time there is a command which comes to it. So when the command, that is event, when the event happens, that event will be an notification to the Lambda function that now you have to get executed. Then that Lambda function will get loaded into the fully managed servers by Amazon. So that means AWS servers which are not managed by you, the managed by Amazon. It will get loaded into it and the function will get executed and the result will be given, whatever result it is. And you will only pay for the time period when this function was getting executed, and that too in milliseconds. 10 milliseconds, 15 milliseconds, 20 milliseconds. The milliseconds till the time your function was getting executed, you will be required to pay the charges for. What you have to do is, you just have to upload your code, tell when this code will get executed. You have to mention the trigger. Okay. So when the trigger comes, the code will get executed. That's it. And at the time when the code is getting executed, you will be paying for that. So pay as you go. Lambda code runs only when the trigger is there. So suppose, say, let me give you a scenario that I have a bucket 1. So I'll name it as niche buck 1. I have a bucket niche buck 2. So as soon as I put a data or a object inside this bucket, it will get replicated over here, right? That was what? Actually, at the back end, Amazon has written a Lambda function, and that Lambda function will get triggered when there is a put object on the bucket. So whenever I put a object inside the bucket, this is a trigger. Trigger to whom? To a Lambda function. And in that Lambda function, I have written a code that copy the object from here and paste it over here. So this is a trigger. So when this trigger happens, this code will be called. This code will copy the object and the metadata information from here and will copy it over here. And then the code will sleep again. And you'll be only required to pay the charges till the time the function was getting executed. Okay. So you can integrate the SQS also over here. So if there are, a lot of objects being put in the bucket and you want an SQS to be there so as to maintain that which object got copied and which was not able to get copied. So although those loggings has to be maintained, so then you can integrate this particular Lambda function with SQS. So you can create a SQS and the Lambda function will fetch the messages from SQS for getting executed. You can, as soon as the object got put, there will be a message delivered in the SQS. SQS will be polled by the Lambda function and the Lambda function will execute the whatever desired results you want to do. You can of course do that. In the practical that I am going to show you, you can do anything via code, guys. If you are not able to see anything on GUI, that doesn't mean that you cannot do it. With the APIs and the CLIs, you can do many more other things, which is actually professional level of AWS. Okay, so we can create the code and then we will set up a trigger. So the same practical we are going to perform. Okay, so I'll create 2 buckets. One will be my bucket 1, another will be my bucket 2. Whenever I put an object in my bucket 1, it will automatically get replicated to my bucket number 2. This is how the Lambda works. This is one of the example that I'm telling. So what you have to do is you have to write the code and you have to mention the trigger when to execute this code. So trigger is actually nothing but various functions. So it could be a put action on a bucket. It could be a time based trigger. So every day at 5 a.m. this code should get executed. That could also be a trigger. Like suppose say I have a EC2 instance, app server 1 and app server 2. I want that these servers should get shut down at 1 a.m. and should get started at 7:30 a.m. in the morning. I want this particular feature to be configured that at 1 a.m. at night, the server should get shut down and 7:30 in the morning, they should come up. I want this thing. So I will create a time-based trigger. So when it is 1 a.m., there will be a trigger which will be sent to the Lambda function. And that Lambda function will actually shut down my EC2 instances. Morning 7:30 a.m., again the trigger will be going to Lambda function 2, which will actually do what? It will power on the system. So what I am doing, I am saving the cost with the help of Lambda functions. The benefits of Lambda are like no server to manage, as we have seen that we haven't created any server, and continuous scaling. If more number of hits are coming to the Lambda function, the compute behind will automatically scale up and the code will run in parallel. so that there is not even a delay. No, it's not required to make the bucket public always. Okay, so the code will run in parallel for each individual trigger. It will not be a single machine. It will be multiple machines who will be working for it, so that there is no delay in the response also. Okay, sub-second billing. So you will be charged for every millisecond that for which your code is being run. So if you run the code for 10 milliseconds, you'll be charged for 10 milliseconds. If you run the code for 100 milliseconds, you'll be charged for 100 milliseconds. That is how the charging occurs. I have told you that it can be integrated with many services. I have shown you all these, that it can be integrated with any of these services which are available over here. Okay. Use cases, so many: data processing, app backend development, control systems, serverless websites, security updates. There are many use cases for it, because it is actually a kind of serverless environment that you create.
So guys, this was our expert from Team K21 Academy, and if in case you missed upon any concept or if you want to dive deeper into the concepts, then we have something really special for you. We have our free class on Amazon AWS Solution Architect Certification for Beginners. Under this free class, you'll be learning about why and who should learn AWS, cloud services, deployment models, and AWS services as well. And the most important part is you'll be getting hands-on labs, job opportunities, along with Docker and Kubernetes in AWS, and amazing, amazing stuff. So if you want to register for this free class, all you have to do is just log on to your browser and type k21academy.com/AWS SA02. And after that, you'll be seeing this kind of interface. You just have to click on book your free seat now, select your event date, add your name, your email address, your phone number, and click on yes, save my seat. And after that, you'll be seeing this kind of page. You just have to save this link on the extreme right, add it to your calendars, and I'll see you in the free class. Till then, keep learning.